I'm Alan Sircom from Hi-Fi Plus. We're here today at the Audio Show Deluxe here at Whittlebury Hall in the centre of England. Look forward to seeing a lot of interesting new stuff here today. Welcome to Indianapolis room in Audio Show Deluxe 2025, and we're making the world debut simultaneously here in the UK and also in the US at Dallas, Texas. These are the Viva Audio Verticale system, and we call it a system because it comes with its own stereo hybrid amplifier that drives the bass department of the speakers. They take control at 180 kilohertz and all the way down. To give you a little bit further information, the cabinet is made out of beech plywood and they weigh 110 kilograms each. They have been working on the horn shape for over 3 years to get the best dispersion out of them. Each speaker on its side has 4 10-inch woofers that the stereo hybrid amplifier is responsible for. Then you have the mid horn, then you have the tweeter, then you have the super tweeter that they make in-house at the top. Driving these speakers on the upper frequencies is the Viva Audio Solista integrated amplifier, all handmade in Italy, point-to-point wired. It's single-ended triode class A and delivers 22 watts. Make no mistake, 22 watts is very, very powerful. We're only using, yes, these are efficient speakers, but in the US, one of my dealers is actually driving MBL speakers, which are 83 dB and 4 ohm and extremely difficult to drive in a bigger room, much higher ceilings than this, and he can reach 93 decibels in that room at around 10 o'clock on the volume. So it's got a lot of guts, it's got a lot of current. Except for a few open baffle designs, it can drive anything. Then we're using the Viva Audio Numerico DAC for our digital source, together with the Oneiros statement music server streamer. All of our cables are Albedo cables from Poland. They're monocrystal silver cables. They make their own cables. They buy the silver from a miner in Poland, smelt it themselves, extruded themselves, and they're all monocrystal silvers.
I'm Tony Crocker. We're here at the Audio Show Deluxe. All the products that you see here were made specifically for the Audio Show Deluxe. We've been around for a number of years, but a couple years ago, we decided to switch over to 3D printing and explore the possibilities of 3D printing, battery power, and microprocessors, and see what that can bring to the audio world and how that can improve the product as well as make it more personal to you. Our headphones are trying to solve the problem of, I don't want a headphone sound, but I can't move my big speakers and amplifier anymore. What can you do for me that can get me somewhere in between? They're a modular based headphone. All the fronts are the same. They're a 50mm driver. The way we change the tone of them is the back half. Once you buy a set of headphones, you're only paying for new back halves to switch from one model to the next. By changing the diameter of the back half as well as the materials, this is Explorer, composed of olive wood and olive wood for neutrality, rosewood for a touch of lower mid-range bump, give you that darkness and richness, with a maple back to bring up that upper mid-range and tighten things up and give you that transient speed. Explorer is the same size, but Explorer uses a port. If you think of a little ear here, a port on the back side, and then a walnut with a maple inlay, slightly different tonality. Transcend is yet another model. They're a little weird looking because the second part that we are trying to solve is the headphone room. And what we're trying to do is give that sound the space to expand. So if you think horn theory or speaker theory, it needs space for it to expand. So working with our various focus groups, they kept wanting a thinner, bigger pad because the thinner and bigger the pad, the bigger the sound stage, the more bass they got out of it. If you think of a traditional pad, yes, it's soft and cushy, but that soft and cushiness absorbs sound from both the outside and the inside. They're angled. They're angled so that when you pull them like this, then they become straight. The idea is that it just rests here and here. and you say, well, it's too tight here, too tight here, you can change these plates for plus and minus. Just like changing toe and camber on a car, these plates will change the angle. Once you've got that done, if you need to say, oh, I need 5 millimeters more or 5 millimeters less in your headband, you just contact us. We print a new one to your size, send it to you, you undo 2 screws, slide it off, slide the leather off, slide it all back together, and now it's customized to fit you. Colors, that's up to you. Always the black for the strong load-bearing parts. Non-load-bearing parts, we can do whatever color you want. That's normally a silk PLA, such as this purple. That's all silk. This is actually a glitter PLA with different PLAs in it, and then your black is your PLA tough. Cables, again, customized. You want covers, you don't want covers, doesn't matter. I use Mogami cable. Now, if you're talking to me in the 2-channel world, yes, I'm building you silver cables. And that's a different subject, not for here. This is all battery-powered amplifier, trying to solve a couple problems here. 115 dB sensitive drivers, meaning picks up great detail, phenomenal detail, also picks up any noise in your system. Go to battery power, I don't have to deal with mains anymore. Yes, I built plenty of battery-powered amplifiers, but building 400 dBs worth of filtering is a really heavy amplifier. Once we go to 3D printing, we got a battery box in the lower, amplifier in the top. It's all a modular design. At some point, years down the road, when your LiPo batteries die, give me a ring and I send you a new battery box. Tell me the colors and I send you a new one. And you take the top off, you plug it onto the new one, and there you go. What you do with the old one is up to you. You can make it a planter for all I care. It has 2 USB inputs. These USB inputs are galvanically isolated. That's a big word. We'll just explain it real quick. When we are sending a signal out of any iPad or computer, whatever, there's always high-speed switching noise from the switching power supply. It's there, and that's what gives it sometimes that harshness. The galvanic isolation isolates the plus and minus off the USB and strips out just the D plus and D minus, the data, which I then send to a 24-bit 192 kilohertz upsampler, which means I take whatever you sent me and I make it high res. Don't care, I'm gonna fill in the bits. Think of that old-timey movie where you spin the cars, you got a horse running, think of adding more cards. Processor-controlled transistors. Problem with Class A transistors is they consume a lot of power because they are on all the time. Put a processor in there, the processor then monitors whether you're using speaker out or headphones, monitors your level out, and sets your power output based upon your power need. This keeps our distortion in a little step. Instead of going like this or like this, it's actually stepped. And then gives me 25% more battery life. The screen right here is your source select and your volume up and down. It is a capacitive touch. Problem is that people did not like push buttons. Takes too long. In the headphone world, they are very impatient. They're like, you know, must give me, because give me more volume. Not fast enough. Okay, fine. So I'll give you capacitive touch. 3D printed filament that goes down, and that filament goes down and touches a capacitive pad. And here you can see we can move down. And I just turn this a little bit so you can see. And then if I gently just hover, I don't even have to touch it. If I hold it, it's going to take a big jump. And I can go up, let it settle down. That was a big jump. I can go up a big jump. And you can see how fast it's moving. Each one of those numbers represents a half dB move. So you can see how fast we can now move with capacitive touch. Or you can do gentle touches. Screens are color-coded to the unit. If this was blue, they'd be blue screens. You can see this is purple, and this is purple here. Those are color-coded. We do a variety of colors there as well. And then finally, we're just powering the whole thing here via Qobuz, so that the users come in here and just select whatever they want. My headphones aren't really tailored to one music or another. I will tell you, though, that say for Transcend, the smaller one with the rosewood, that's going to be a little bit smaller sound stage, a little bit more kind of what you're used to in the headphone world, just a little bit of tonality. This is going to be big sound stage when we're talking ethereal, because we are talking really, I just put them on my head so you can see how big they are. They don't weigh anything. They're all less, they're about half a pound, about 9 ounces. You can see how big they are on me. Big sound stage, big headphones. The headphones, this particular model is $2,500 USD, Transcend is $2,350. Everything we do is cost plus. Cost of parts, $75 for labor, 35% markup. When you move from one headphone to the next, you are not buying a new headphone, you're buying a new back. So it's only 200 USD. So in essence, with the three models, if you start with Transcend, it's $23.50 plus 400 plus 400. Sorry, plus, no, 200 plus 200, so $400 more. So $27.50, and you have all three. Headbands, depends on what you choose, that's alligator, that's an extra 50. Amplifier, yes, I know it's expensive. 16K USD, and yeah, I'm only making a 35% margin on that. I don't expect to sell them. The reason I have these is it is a modular design and it supports our other products. If you were at Southwest Audio Show in Texas this weekend, you would see something that looked like this, except it didn't have this top because we stripped off the amplifier and you just saw the preamplifier because it's just a motherboard with modules. So you got a DAC module, a preamp module, a source select module. It's just modules to plug in, plug and play. And then you would have seen two bigger boxes, which are the 11-watt mono blocks. They were only talking 11,000 for two 11-watt mono blocks and then 12,000 for the preamp. So this is kind of everything combined into one, and it supports other products. So we don't really intend to sell a lot of these. It's really just a product to put all the technology into one to show what we can do. We also do tubes as well. That's processor controlled, but flying from the US to London with tubes from the 1930s just didn't seem like a good idea. Well, I hope you all enjoyed that, and I hope everybody had a good show.
Good afternoon, everybody, and just greetings from the Audio Show Deluxe at Whittlebury Park. I want to talk to you today about the Oneiros loudspeaker that we've introduced. My name is Jerry Bloomfield. I'm the MD of the company. It's a 100% carbon fiber monocoque loudspeaker. It's built in all the area around here in Motorsport Valley, and it utilizes F1 Tier 1 construction techniques and Tier 1 luxury automotive finishers to do the final engineering part of the machining that you see before you today. You've got two 10-inch Twaron graphene woofers here. You've got two 3-inch domes, mid-ranges, which are Dyneema graphene domes, and you've got a 1-inch natural diamond dome tweeter in the center. It's ported. There are two port tubes in it, one on each side here underneath the grill that you see there in the middle. It's very much a break from the normal box that you'll see everybody else using and fighting. This cabinet is as I said earlier, is 100% carbon fiber monocoque. So it is effectively a sandwich of 1mm layer of carbon fiber with an 8mm layer of effectively sandwich in between. The front baffle is aluminium, and it starts off at a 550 kilo billet of aluminium and machines down to 22 kilos. There's an awful lot of work goes into this. There's 60 hours in total of machining on 3-axis CNC, 30 hours on the front and 30 hours on the back. Bespoke for us genuinely means that the customer has more than the usual number of options. The customer can have effectively any color they want. They can have the front here anodized or polished, depending on the colors they want. That's attainable. The foot here, exactly the same. So you can have any color combination, any finish combination that you want. You can have two levels of bespoke on the veneer as well if you want it. You can have what we call our sort of more kind of regular veneers, for want of a better expression, which are the more linear veneers. If you want something a bit more exotic, like a burr veneer, then that can also be done, but that sort of takes it up another step of bespoke. One last thing on that, if you are really keen on choosing your veneer, we can actually fly you over to the veneer company. You can choose your log and watch your veneer being made at the same time. They are available now, and the price starts at $695,000 a pair.
My name is Craig Milnes. I'm design director and I'm part of a team of people which incorporates Christina Mills, who is the managing director, and my son, in actual fact, is the marketing and international sales director. And we're a family business. We operate from, and I've always operated from, Sheffield. And our reason for existence is based upon the fact that we have tried to innovate in audio with, especially material science, but with engineering and technological breakthroughs that have brought different products to the market which didn't exist before. And in fact, that's been quite a challenge, because if you set yourself the standard whereby you can't bring something to the market unless it brings something new, sometimes it can take a very long time. So in the case of the GMT, for example, it took nearly 20 years. And when you think that the company started with a record player, and this is the sub-chassis that was in that record player, which is made from carbon fibre composite, when you think that that's where we started, it's a little bit sad to think that it took us so long to create another record player that was of a good quality. The Full Circle was a great turntable, but it wasn't the kind of league that we were seeking to be in. And a lot of research and development was done in order to be able to not only initiate the initial ideas as to how the turntable would be created, but also to make a stand in terms of what we were trying to achieve in the long term. And what came out of that whole process in the initial phases was the idea that we should create not only a record player that was going to break certain envelopes that have constrained record players to date, but also a record player that was modular. And that modular design was critical because we felt that we ought to bring a product to the market which would be capable of starting at a low level and then building up over time, rather than having lots and lots of different turntables. Now the problem with that is that if you take that approach, it means that you've got to really bring the top one out first, because that's going to set your standard and it's going to say, look at how good this is, but you can have all these other products that can allow you to build up to it. So that's why it's taken so long, really, because we've had to not only create a system, an ecosystem, if you like, of designs, but we've also had to make sure that they all fit together subsequently and build up. So the model that's here in front of you is the Prime Meridian, and this is the second to the top, if you like. The top one is the GMT1 system, and the reason why we chose GMT is because time is a critical factor in record player design. And GMT stands for, as everybody knows, it stands for Greenwich Mean Time, which is where time begins as far as England is concerned, so it's appropriate. Prime Meridian is the next one down. The next one down after that is going to be Meridian, it's going to be the Greenwich, because everybody knows Greenwich Mean Time is what the company has given this title to this record player, because, as I've already said, time is very important. And in order to deal with the problem of time, we have created a direct drive motor. Now, we went down a lot of different avenues to get to this stage, and a lot of them didn't work. And one of them was this little magnetic drive that I'm holding here. It looks like it's geared with cogs, but in fact it's not. You can see there's a ratio there between the two halves. Unfortunately, we couldn't get this one to work because it cogged too much. It was based on the idea of getting a high inertia but without mass. But the stator that was developed in this particular design went on and was possible to become part of another project. So we've had multiple projects running. Some of them have been funded by government and some of them haven't. The Mondrian project was about 170,000, and then the project that we got as a result of COVID, when we had to transfer all our R&D budget into expanding the company to allow people to keep working, that was 375,000, I think it was. So public funding, your taxes, my tax, has gone into the creation of this product. So thank you for that. And the idea of investing in a product like this is that it's about innovation. You can't win that sort of funding unless you've got novel ideas and you've got a novel team of people to make it happen. So what we did, we brought together Sheffield Hallam University, so we had Dr. John Travis, we had Professor Graham Cochrane, and in particular for the magnetic drive, a very influential person was Dr. Faris Al-Naima, who in actual fact developed all the electromagnetic systems in our loudspeaker designs. So with that team at the university, we had the capability of doing all the engineering work that was required for the motor. But then we also needed the electronics drive, and that's where Cass Audio came in, and they developed all the digital electronics, because when you design a non-classical motor, it throws up lots of issues. And one of the biggest issues is because the stator and the rotor are so far apart, in order to start the system, you've got to have an algorithm, a computer-driven algorithm that kicks the motor into motion. But once it's up to synchronicity, it locks, and there's no feedback loop, it just locks on and it stays there. It's a very large direct drive, and it's made up of 21 field coils, air core, which are radially orientated. And they relate to 14 neodymium fixed magnets, which are on the rotor, which is internally mounted. And we use acrylic to do this mounting, because any metal structures involved in the assembly of the motor would interact with those fields, those flux fields. And acrylic is also used in the platter because of the fact that we want the acoustic impedance of the platter to be identical to the vinyl, so that energy from the vinyl dissipates freely into the acrylic without creating reflections. So the motor has overcome one of the biggest problems, which is time. But of course, motors always usually bring a noise signature with them. That's if they're based on conventional designs. But in this case, with the design that we've got here, the drive frequency for the three-phase system is below 4 Hertz. So essentially, we've created a rotary system which is incredibly accurate, doesn't suffer from the wow and flutter problems because of the low cogging, and has got zero noise. So this is something that is quite radically different from any other turntable that has been created previously, and sets it apart from those turntables. And of course, it's incredibly reliable because of the way it's made. There's just a single moving part, which is the tungsten carbide shaft, which goes onto a zirconium ball at the bottom. So everything else is electromagnetic. Of course, the motor is only one part of a turntable, and in order to create a system, the rack system was developed 10 years before the actual turntable was released. That just shows again how long we've been working on this. But in addition to that, of course, is the tone arm. The technology that has been used to create this tone arm is quite different to anything that has been seen before. And it's based on a manufacturing technology that was developed by a number of scientists at the Advanced Manufacturing Research Centre, because we took a model, and it was made in wax initially. It looked a little bit like this, the wax model, and they kindly grew it very quickly from this polymer, which is photosensitive. So this is a 3D printed polymer version of the idea that was used to discuss with the engineers at the AMRC what we were looking for. And during the discussion, I drew in various things and said it needs to separate here so that we can get the carbon to fit in, and we need this to be transparent. And they then also came up with this idea of how it could be bolted together. And then that idea went into, literally within days, went into a titanium structure. And the first titanium structure was solid. This one that we're looking at here is solid just from here backwards. And then it's tessellated in here, and the hoop that goes around the front is like a shell. So you're looking at here the kind of technology which is highly optimized, what's called surface topology created engineering. And what that means is basically there isn't a single particulate of titanium here that doesn't need to be here for a job. It's all highly optimized. There is what is also referred to in engineering zero redundancy. So there's nothing there that shouldn't be there. It's as if nature would, if nature was to grow it, a tone arm, it would look like this, is what we postulate and put forward to people. So what we've got here is not only a structure which is highly optimized, but it also marries to a carbon tone arm. And the carbon tone arm has got a number of features in it as well, but I can't go into those in detail, other than to talk about the cartridge. because the cartridge, as you can see, is somewhat different also. It's a tessellated structure again. So like the tone arm where you can see through it because of the honeycomb, we've taken titanium, but we've reduced its mass significantly. We've kept a very high stiffness due to the geometry, but we've tessellated it and taken out mass where it's not required. So as a result, we have an open structure, but at the same time, it's a closed structure, which is impossible to do with a CNC machine in titanium. You can't make hexagons like you can see on here. Well, you could, but it would take a very long time and be enormously expensive. And then we've got a fin on the top. So what we're trying to do with the tone arm, and what I think is very important, is we're trying to deal with the energy that's being injected into the system from the only remaining place, and that is from the stylus itself. So if you deal with this problem here as much as you possibly can with the stiffest, most highly damped materials you can throw at the problem, then what you're doing is reducing the burden on the tone arm itself. So by eliminating as much as possible the energy going into the arm at this point, the tone arm is much freer and less burdened with those resonant frequencies that cause the arm to get excited. And all arms get excited, you can't stop it. This construction of titanium at the end of the arm is just as important as the titanium structures at the opposite end of the tone arm. And the titanium is also important because it doesn't interact with the magnetic fields like other metals do, which is a very interesting and exciting finding that we found during the development of this. The other thing about the cartridge is that the other resonant structure that's in every cartridge on the planet is of course that tiny little beam of material that is called the cantilever, and typically the cantilever is just a beam that's just left to its own devices. It's got rubber O-rings on it, of course, but usually it's just a free supported member that can just resonate at the frequencies of audio frequencies that you will perceive, and that's why you can tell the difference between a carbon boron type cantilever or an aluminium cantilever or a diamond cantilever. You can hear the difference. Like every material, it's perceptible. So what we do to try and eliminate that characteristic is we put a UD carbon fibre tube onto the cantilever, offset to one side towards the pivot, and that not only elevates the stiffness of the cantilever, because it's the middle where it starts. It actually starts to resonate in this axis, its length first. It goes like that. And then it starts to do that, bend in the middle. So if you can stop that, that's one of the characteristics that you can eliminate before it creates a problem and before it becomes part of the music, and it shouldn't be there. So although it might look like this cartridge is a relatively small and insignificant addition, and it looks like many other cartridges, there's a lot of new things in this cartridge. And the other important thing I think is that has to be talked about before I finish, and that is the wire, because the wire in all tone arms is one of the biggest issues that exist that most people don't often fully understand. And the tone arm wire is often concealed, and you've no idea what's happening, whether it's twisting or not. You can't see it, you're just hoping that it's right. But of course, any turning forces or twisting or bending moments in that wire is going to impact directly on that little sensitive rubber suspension system that's on the cantilever. And therefore, if you throw it out of its zero reference point, it's immediately skewed and it's incorrect and it's not doing it can't do its job right. So one of the biggest issues is to have a wire that not only you can see what it's doing, but it's incredibly flexible. And this particular wire is a wire that we have searched for a very long time and finally found something that will actually do this. But not only that, the wire goes through this titanium structure and emerges above the bearing. So the amount of actual movement that this wire goes through is almost negligible to begin with. Even before the wire starts to move, there's hardly any movement being subjected to it in the first place. And that is a result of the fact that we've conceived of a completely different way of exiting the tiny little signals that are on those wires. And bear in mind that that wire is also an aerial. Even though it's a short piece of wire, it will still behave as an aerial. So whatever is picked up by that aerial is going to be amplified by 1,000 times. And that's on both channels. So there's a lot of noise gets into wire from tone arms, and there's a lot of issues with tone arm wire. But this particular design overcomes many of those because of this structure that's been created to allow that wire to be plugged in at the earliest opportunity. Obviously there's a lot of other things about the turntable, like the fact that it can be remotely controlled. The VTA system is piezo actuated, which is what they use for tracking telescopes trillions of light years away. It's insane what they can do. And we also use engineering components like this hydraulic chuck, which is patented by a Swedish company, which is taken straight out of a CNC machine shop, which gives us nano precision accuracy of the bearing position. So the geometry that we set up on the tone arm when we supply it with the cartridge fitted is bang on. You don't have to get somebody in to do that. You don't have to try and do it yourself. It's actually sent to you, fully dialed in. You just put it onto the bearing, plug it in, and off you go. And similarly, if you want to change the tone arm, you just unscrew it, unplug it, lift it off the bearing, put the other tone arm. You can change from one tone arm to a different cartridge within a minute. There's a lot of different things about how the tone arm works, how it's operated. And of course, because you can adjust the VTA from the seating position, it no longer means that you're stood next to the record player adjusting the VTA and trying to hear what the speakers are doing, usually in the worst possible place in the room, probably. So there's a lot of things like that, which are details which I'm not going to go into, but obviously they're part and parcel of a whole system approach to the redesign of a piece of equipment which is going to be playing valuable records and hopefully protecting those records from damage. And that's one of the key things about this design, is it's a reference system that is capable of protecting and looking after a valuable vinyl collection. And that, at the end of the day, is what it's all about, is playing it, looking after it, preserving it for those who follow you.